Hello, everybody. Today is Wednesday, May 24th in almost all of the whole world right now. And we're going to be talking about four new chips, 16 through 19. My name is Dan Perry, and I'm a technical writer here at Chia. And we're here with Yiming Song. Do you want to introduce yourself quick?
Hello. Yes, thanks, Dan. My name's Eming Song. I'm on the product management team here, responsible generally for wallets and how we bring sort of reference implementations of our primitives out to market.
Great. So we have four new chips for everybody that we just opened up this week. And I am going to share my screen so we can take a look. This is just an overview of the status of all of the chips that we currently have. And the ones we'll be talking about today are these four that I'm highlighting in draft. And it seems like a lot, but really it's kind of only two chips because two of them are metadata chips that go with the VC1 chip in a similar way to how we have that chip 7 that goes with, that's a metadata chip for the NFT standard that we released last year. So the big two ones that are new here are 16, that's the verifiable credentials, and 19, the restricted cats. So how about this? I'll give a quick overview of the verifiable credentials. And Yiming, do you mind walking us through just kind of how they're used once I'm done with that?
Yeah, sure.
And Quex just let me know that he'll be on in just a few minutes, and he can give the technical overview of the Chia Lisp part. So verifiable credentials, basically they're a form of identity that you can get on the on Chia's blockchain. And the way it works, the very high level overview is you'll be able to go to a credential issuer and you need to send them some sort of information identifying yourself. And it depends on what kind of identity you are trying to get. Maybe that would be proving that you are over 18 years old or not a US citizen or are a US citizen or something along those lines, some sort of factual information about yourself. The credential issuer would then have to look into your credentials. So maybe you scan a copy of your passport or driver's license or something along those lines. And then they will issue you a credential, which will sit in your Chia wallet. And you'll be able to use that in various different ways. There's a bunch of different use cases. So how about Yiming? Would you mind taking it from here and let
Yeah,
maybe go over some of the use cases?
yeah, and I think just to set a little bit more context, in this verifiable credential system, there are three primary parties or roles, as Dan mentioned, right? The first is what we'll call the subject. So this is the one who is going to be asking for a VC issued. They're going to be showing proof for whatever claims of information that they are validating. They're going to send that over to a VC issuer, right? So a VC issuer is someone who's going to issue the VC. They're going to confirm that the statements made by the subject are true. And then the third is the verifier. The verifier is the one who's going to say, I trust the credential issuer and the claims that they are making about this subject or holder, and therefore all the information is valid, and they will be able to perform the task or enter the gate or whatever sort of is the limiting factor for why the verification is being done in the first place. It could also be done in relation to a transaction as well. So it's important to understand those three because each of those three kind of are its own little system. There are a set of tools and capabilities that each need to have in order to hold or issue a VC, as well as use the VC in the context of, again, signing into a site or however the VC is going to be used. So we have a few different use cases that we have highlighted here. And I'll actually go to restricted cats last, just because we're gonna go deeper into that one in the last chip. But just to give some examples of people of what a VC can be and what that means in sort of practical use cases, right? So these other examples, like a company badge, is a VC because the employer, who is the VC issuer, is the one who can issue a badge to any of the employees that are actively working for the company. So the people who are actively working for the company are the subject, and they typically will verify that they are, one, they are who they say they are, and then two, that they actively work for the company. An IT admin is able to check that to say, hey, yes, this, the email address that sent me this request is in our system. And, if you've ever joined a new company, you provide, driver's license, so proof of identity, all that information is there to say, okay, yes, you are this person, and the company can confirm, yes, you are an employee. Therefore, when they issue you a badge, that serves as a verifiable credential. And then that credential then can be used in different ways, whether it is to get access to a building, get access to your system, perform different, have different roles attributed to it. Those all kind of are based on having this credential, whether sort of in a physical form or in digital form, that can then be used to, gate you into, at least from an enterprise side, into, the intranet or, local resources. Other forms of credentials can be like academic credentials. So this can take the form of diplomas. So imagine you graduated from Harvard, you get a diploma from them. Harvard should be the only one who can issue you issue anybody a diploma that confirms that you've attended and graduated from that university. And so again, in this case, Harvard would be the VC issuer. The person who graduated is the subject or holder. And then the verifier could be, maybe social clubs that require proof of attendance and graduation from Harvard in order to participate in a social club. It could be, on your resume, right? So you can use that to say, yes, I attended and graduated Harvard. And all of these are, again, the fundamental sort of aspect of verifiable credentials is that these attestations are, when they're verified by the VC issuer, there are signatures and proofs that are created related to that can help prevent any sort of tampering of that information that's been validated. You can go into technical certifications as well, right? So I completed this course. The course provider can be the issuer. And then when you get into healthcare and supply chain management, again, it's all kind of the same system applied in different verticals, where there is a centralized sort of trusted issuer that is part of this ecosystem that any verifier can use to say, yes, I believe that the information that this VC issuer is presented or has issued are allowed in my system, and therefore all subjects or credential holders with VCs issued from those issuers are able to pass our verification checks. And so that's kind of how VCs work at a very broad sense of the case. Now, there are two different aspects of this. There's a lot of these off-chain use cases. So imagine, as a company badge, it's completely off-chain, right? And so the cryptography is there to use to verify that the credential has not been tampered with. But there aren't that many there's no direct sort of blockchain transaction that is happening when you're verifying that system works. Now, the other half is when you look at sort of on-chain transactions, that's where a lot of the interesting use cases come about. And we'll touch quickly upon the credential restricted CATs, but we'll obviously go deeper into that when we cover that chip. But the beauty of this is being able to do on-chain transactions that are restricted based on having specific VCs in your wallet that are on-chain in order to trade. And that's why we call them restricted Chia asset tokens or restricted CATs, is because the only way for you to receive or buy these tokens is if you have a a VC in your wallet in order to trade those tokens. And so, we'll talk about this a little bit more, but the VCs in this case will be a know your customer, or KYC VC. That has, you will have, as a subject holder, will have gone through and done all the validation to make sure that you've gone through the KYC process. But holding one of these VCs will allow you to trade a restricted Chia asset token. And so these are a little bit different than a standard Chia asset token, where it's completely non-fungible and you can openly trade them on Dexy or any other sort of marketplace. But here, these can also be tradable, but as a receiver of these restricted Chia asset tokens, you will need to have a VC in your wallet, a valid VC in your wallet.
Thanks. You
Yeah.
You want to keep going?
No. Go ahead. I think we can kind of move to the next section then.
I mean, I think that's a great overview of what VCs are and how they can be used at a high level. I think we should go into the more technical details now. Matt, if you're able to, would you mind introducing yourself first to us?
Sure. Yeah. My name is Matt. On Keybase Discord, I'm in Quexington, and I've been, working on Chia for the past couple of years. I'm the one implementing this primitive, so I know all of the deep and dirty technical details.
All right, it's great to have you here. Do you want to maybe start out with this diagram that you have made for this?
Sure. So the one that you're zoomed in on is actually not super important. It's just kind of the launch process of a VC. Yeah. The one that's kind of more important is the one to the right over here. Yeah. So VC is a lot of puzzles that are all kind of layered on top of each other. It looks sort of like an NFT with the ownership layer that we normally use for like the DIDs and the NFTs. And minus the metadata layer, because we want the intricacies of the puzzles make it so that you want to basically check the metadata every single time, and that's not how our current NFT that's not how the metadata layer works, but it is how the DID layer works. So anyway, so a VC is this stack of puzzles that's quite very modular, and it has a couple of different branches. So it's a singleton, obviously, the ownership layer, which is recycled from NFTs, and we're using which basically holds on to who the provider of the VC is. That is the person, the VC issuer. So the university or the KYC provider, etc. You're storing all of that information at the NFT ownership layer, and then the transfer program, which for our NFTs are normally used for royalties, we're repurposing it in VCs to basically check every single time that the proofs in the VC were put there in a auditably correct manner. Right? So someone didn't just add random proofs and a random DID to their VC. The DID that's in the VC is the one that added the proofs. And so therefore you can be assured by the Chia list that when this VC makes an announcement, the proofs did in fact come from the DID that it says it did. So that's the right side over there. It's got a couple of puzzles that are pretty technical and are really just in support of that idea. And then on the left side over here, we've got the kind of custody section of the VC, which could, for when we get to the restricted CATS chip, we'll see that this left side isn't actually committed to by restricted CATS. It just wants an inner puzzle of any kind. But the way that we're proposing that VCs be issued by default from a VC provider is with this kind of the technical term that I've put forward is viral backdoor, which sounds scarier than it is. Basically, this allows the VC provider, like the KYC provider or the university or whatever, to basically go into a VC and revoke themselves out of the VC at any time. So the user can be like, going around authorizing transactions with their VC, et cetera. But at some point, maybe one of their proofs becomes invalid or expires or something. And then the VC provider is going to go to their VC and it's going to yank out all of their proofs as well as any involvement in the VC that they had. So the user will be kind of left with like an empty VC that doesn't have this backdoor in it anymore. And but also won't have any proofs and won't be able to authorize any transactions that it had previously been doing. So that's kind of the structure of a VC and the way that it kind of branches. There's a whole bunch of chia lists. All of these blobs represent a puzzle.
Yeah, I could go back
like,
to that too, or to the description of the puzzles anyway.
Right.
So we have that in this specification part of the chip. So we have all those puzzles laid out here in English instead of that diagram. And would you mind just reiterating one more time for the revocation part? First of all, what would be the reason for it? And then why does it function this way? The way that it does?
Sure. So the reason that you might revoke a VC is, like I said, because someone's proof has expired, right? They were a U.S. citizen, now they're not, or they had a driver's license, but the driver's license expired, or without kind of passive expiration, you just have decided that their VC is too old and we're going to take it away and make them get a new one. So that's a reason why you might want to revoke a VC. And the way that it works is you're not like the diagram is a little bit outdated. I think it said brick puzzle in there. But it's not actually bricking the VC as it says in the chip here. What it's doing is it's removing all of the proofs and it's removing the provider's DID, and the VC is left in a kind of an empty state where it has no proofs, no provider, but it does still belong to the user. So if the user custodied any money with the VC or anything weird like that, they can still use the VC. They can still go to another provider and get more proofs put into it or something, or the same provider if the provider was just revoking it for expiration purposes, right? So the VC gets wiped clean, and the backdoor is removed, and the user is left with this empty VC that they can go to another provider and get all of that re-added.
Okay, thanks, Matt. Why don't I could take questions now just for so far on this chip before we move on. I think after this we should talk about the two metadata chips. Does anyone have questions right off the bat? Just go ahead and ask. Well, I guess not so far. I'll ask again later too, and you can go ahead and ask questions in the chat too. I'm checking that out. So the next chip that we have is this metadata chip that goes with the VC standard, and that's going to store the off-chain information pertaining to the credentials. And this is modeled based on the W3C verifiable credential standard. So it's meant to be conformant with that standard. And so the basic chip has all of this information, the context that it involves, the identifier, format, type, and maybe a little bit more interesting is the actual example JSON file that's included with this chip. So it currently looks something like this, where you're going to have your you'll have an issuance date along with the chip, and you'll be able to specify this is the chip that this metadata is using. And then the heart of it, or the meat of it, will be these proofs. You can see for this example, we're doing a KYC credential. Eman went over a whole bunch of different potential other examples that are not KYC related, but this is the one example that we have. And then you'll be able to add strings for various proofs. And so one might be that you're over 18, and that'll just say true. You'll be able to put your nationality, your residency. There's no exact proofs that are required for this chip. And in fact, we have the third chip then is another metadata standard. And that's going to be the proofs specifically for KYC verifiable credentials. And so this is the context here, or the schema. And so this is the third chip. This is the KYC VC. And then these are some examples that go with it. And so the idea here the reason we split this into two separate metadata chips is because there's different types of verifiable credentials, and this is going to be the KYC verifiable credentials will just be one example. And so you'll be able to create other metadata chips in theory, although we're not doing this yet, but in theory, we'll have more use cases in the future other than just KYC. And then these are going to be the proofs that we have so far for this example. In order to be W3C compliant or conformant, we need to have string values. So we'll be able to say nationality and then the actual country. And then this will be according to the international standards using 2 letters is how we're doing it for now. However, this is for the off-chain metadata, but within the actual Chia list, that requires Boolean values. So it has to be true or false. So we do need a sort of translation layer to go between the off-chain metadata and then on-chain. And that's all going to be part of the standard as well. Yiming, do you have more to add about these metadata chips?
Yeah, so I think the important part is sort of making sure that we're conformant with the W3C standard. For sort of this, like the KYC specific standard, again, this is to allow anybody who wanted to provide a KYC VC should be following sort of these expected data proofs that would be included. We do expect that other credentials like diplomas or others, they will have their own sort of like, here's the expected proofs that would be in those, and that those would be separately defined. And so that's how, you sort of take that subset and apply it back into the previous metadata chip to say, okay, now this is the full construction of all the information that would be in this off-chain metadata. But it really depends on sort of what the credential is going to be used for. So if it's a diploma, then there's a specific set of proofs. If it's here like KYC, these are going to be a specific set of proofs as well. It's possible that one VC issuer could do all of the above, but the standardization of this through the chips is to define sort of any verifier who's looking to reuse or to use these VCs. They know what proofs that they should be expecting when they check any credential holder's VC. And that's why there's sort of the structure of the 3, where the first one, it really defines sort of the Chia list for the smart contract level, and then you have these 2 that define the off-chain metadata and the expected set of proofs based on the type of credential that it's going to represent. Here specifically, KYC is the first, but also not the last. And so we expect, and that's kind of how all 3 of these chips ultimately work together to, really bring our first example of KYC VCs into reality.
All right, thanks, Yiming. So why don't we move on to the final chip? And one second here. That's going to be the restricted CAT standard. This, as Yiming alluded to before, is going to be a special type of CAT or Chia asset token that will be wrapped with this new capability that it can restrict who is allowed to own it. And specifically, we're going to be using this for the KYC verifiable credentials for the first use case. Yiming, you mind going into more details of the overview of how or why we would want to have restricted CATs and what they're for?
Yeah. So we've generically called them restricted CATs because there are going to be restrictions that a wallet owner needs to have passed in order to trade or transact with these CATs. Why that becomes important, why that is important for us, is when we look at tokenizing securities or tokenizing other assets that may fall under some form of regulatory control, it becomes important that these are enforceable on chain, such that you can actually transact the tokens. We can leverage our existing sort of offers, primitive and other capabilities to trade these in a fully decentralized model. A lot of the systems in place today that do allow for trading of regulatory or tokens that need to be regulatory compliant typically fall within very centralized systems. And leveraging sort of all the benefits and advantages that the Chia blockchain provides, especially around offers, we want to ensure that you can do this in a much more decentralized model as well. And so that's where these restricted cats really come into play and allow the ability to tokenize your equity or whatever real world assets that you want to tokenize. And based on those regulatory restrictions that are required or that need to be enforced, these cats can then be created to map to those real world assets and still enforce the restrictions on chain.
All right, thanks, Yimeng. And Matt, would you mind walking us through the Chia Lisp part of this and how the puzzle works?
Sure. So this is much simpler from Chia Lisp's perspective than the verifiable credentials are. It's just one puzzle. I don't know how much we're committing to the proofs checker in this chip. We have like a default one that we're launching with and that our wallet supports, but you can have new ones that are like as complex as you want them to be later on. But anyway, it's a single puzzle, and it does a couple of things. It will wrap all of the children in itself, so it's viral. It won't be able to be escaped. And B, it's going to assert an announcement from a VC, and basically prove that VC has some certain Merkle tree of proofs in it. And then it's going to pass all of the proofs that were proven to this proofs checker, which, like I said, is flexible. And the proofs checker is going to return, yeah, this VC is authorized to, trade me, or no, it's not, and it's going to throw an error. And then it's also going to check that the VC is in a list of authorized providers. So as a restricted cat issuer, I'm going to choose, I trust this KYC provider and this KYC provider to prove that people are citizens, for example. And I'm only going to let people who have VCs from those providers trade me. And as long as the VCs from those providers say that they are, in fact, US citizens. And once it's passed all of those checks, and the announcement assertion checks out, then it's going to make announcements of all of the outputs that it's creating. And this is so that a VC can know exactly what the cat that it's authorizing is doing. And it can assert those announcements to make sure that it's only authorizing the cat to do one very specific thing, or multiple very specific things. And that kind of completes the loop there. So the VC makes sure that the cat is doing exactly what it said it should do. And then the cat makes sure the VC is authorized to trade it. And then once all of that checks out, the transaction is able to go through.
All right, thanks for that explanation. I see we have a question from John, and I'll just read it for those watching this on YouTube later. Can you explain again why the optional off-chain proofs in the KYC VC proof structure are all string key value pairs? John thinks the W3C VC data model actually does allow for Booleans. I don't have that up in front of me, but I thought it had to be string for the W3C, but it could be wrong there. If I am, then we potentially could make some changes. Do you know more about the CMAIN?
I don't off the top of my head. I think you know, if it does, again, I think the off-chain data can be sort of whatever structure. The intent is that we do follow the W3C standard here. What becomes important when you get down into the Chia Lisp is that translation layer that takes, you know, how we construct this off-chain data and map it into what's supported at the Chia Lisp layer, which is strictly just Boolean. So I think the off-chain can really be represented, you know, anyway, so long as we're W3C conformant. So we can go take a look at that and just confirm that, you know, if it does support multiple structures there, that, you know, we can add that in also. But what's really important is taking that off-chain metadata structure, and then when it gets translated into the on-chain proofs, that's the translation layer that's going to turn it into Boolean specific at the Chia Lisp layer.
Yeah, just to elaborate that on that a little tiny bit. Like I said, the proof checker is flexible, and the default one we're doing is just like only Booleans. But that's just like what we're launching with for default. It's like the simplest, like easiest to implement and cheapest from a Chia Lisp perspective. And you could make a proof checker that is super flexible, like either this person has to be over 18 or they have to have a signature from their parent or guardian. And, you know, like some other proof. So these proof checkers can end up getting really complex if you want them to be. It's really up to you what criteria the proofs in a VC must meet.
Right. And there's a small note about that in the chip. And I should point out that these are chips, they're Chia improvement proposals. So these can be absolutely modified before they're finalized. They're not at all written in stone. And that's why we're having this meeting. So we appreciate all your feedback. And especially on the metadata chips, wallet developers will especially be interested in these, and we'll need to get them nailed down and get a high level of community support to get them through. So thanks for all your feedback on them. Okay, that's the only question so far in the chat room. Does anyone else have questions for now? And you can just unmute and ask.
Yeah, so the biggest question that I ask myself is, coming from a technical perspective and seeing that there is on-chain stuff going on and off-chain stuff going on, and not so much looking at the restricted cache, but only at the VCs itself. I'm asking myself, how does the JSON thing that the W3C standard defines, like the where the proof is described, how does this get linked to the on-chain VC? So how do they link together? Is there a link, or is it only something that happens off chain and is only linked through the proof root hash, or how do you? So that's what a little bit unclear for me.
I believe that will need to be developed at the wallet level. And
so the VC,
yeah, I think
the VC only knows about the root, not the root hash from the proofs inside, and those proofs are just key value pairs, I think, right? Is that correct?
Right. Even right now, it's actually even just key Boolean pairs.
It's key Boolean pairs, okay. And so that's what the Merkle tree contains, and the VC even doesn't even store those key value pairs, but only the root hash of that Merkle tree, correct?
That's right. Yeah, you
okay.
add the key value or the key Boolean pairs into your wallet so that you can prove things later when you're doing like RCAT transactions and stuff like that. But the only thing that's actually revealed on chain until you prove something is the root hash.
Okay, and now if I'm an issuer and say I issue those KYC VCs, then I would create a VC that contains, for example, age over 18 true in its Merkle tree, would store the root hash in the VC and send that over. And in the same at the same time, I'm sending over the JSON document of the thing that that is actually described in the W3C standard, and then the user can take those two things and show them to a verifier and then get it verified.
Yeah, I think you've got it basically correct.
Okay. So, but compared to an NFT, there's nothing that points to this JSON document inside the token.
No, there's not. Other than
Okay.
if the root hash could do that in some way, but other than that, no.
Yeah. So there is no field. I was just looking at whether there is, but if there isn't, then I think I understand it. And then the wallets have to somehow figure out whether they want to store the JSON or whether it's job of the issuer to store that. So that seems to be outside of the scope of those chips, correct?
That's right. Yeah.
Correct. Yeah.
Okay. Yeah, that answers my question. Thank you.
Great. Any other questions? Well, sounds like no. So we can wrap it up then. And I want to thank everybody for coming and watching this. And we're looking for your feedback on all of these chips. So go ahead and leave your reviews in the PRs, and we can always chat on Discord. And we also have our discourse server, which is developers.chia.net. And that has a nice chat room for each of these chips as well. And we will look forward to keeping in touch with everybody as we push these along the process. So thanks again for coming out.
And Dan, we're good with also just people reaching out to us in Keybase as well, right?
Oh yeah, yeah, we've moved our public discourse onto Discord, but we still internally use Keybase. So my DMs are open on Keybase, and I'm not sure if Yiming and Matt, are you guys okay with getting DMs on Keybase?
Yeah.
Yeah, I don't generally don't mind.
As long as it's some technical question, I guess.
If it would help others to know, then I would prefer it go on a public channel. But if it's like something specific to you and stuff like that, then I don't mind.
Yeah, that's a good way of looking at it. Okay, thanks again, everybody. We'll catch you later.
Thanks, everyone.